Hello everyone. So in today's session, we will be seeing file handling functions. We have already seen how to open a file, how to write contents into the file, and how to read contents from a file. So today we will see how we can access contents in a file in a random order. So if you are considering an array, you will be having different values and you can access the element in any location using an index value. Similarly, if you are having a file, once you open the file pointer will be pointing to the start of the file, and using some file handling functions, you can actually access the content of files in a random order. Okay, so we will see those functions. So today we'll be seeing three functions: ftell, fseek, and rewind. We'll see those functions with an example. So I have created a text file over here. You can see there are certain lines of text file, and in the program I am going to use these functions. First, we will see what is a ftell function. So, as the name suggests, it will tell the user where the pointer is currently located. Okay. Suppose if you are pointing to a particular file, it will be giving the position of that pointer with respect to the start of the file. So, if the pointer is already at the start of the file, it will be giving a value 0. And suppose if the pointer is say 5 bytes away from the start, it will be giving the value 5. Okay, we'll see how it works. So I have created a file pointer as fp, and I have opened the file test.txt, and this is the usage of tell function ftell with that particular file pointer. It will be returning an integer value is stored in position. So here, as the file is opened, by default it will be at the starting position. So we'll just run the code and we will see whether we are getting the value as 0. Okay, you can see the value is printing as 0. Now we will do one thing. So I am using two functions fkc, and again I am using the same function, which means I have read two characters from the file. So A has been read and then B has been read, which means currently file pointer will be pointing to C. So after that, I'm again displaying the position. You will see it. Here you can see initially when file was opened, the pointer was at the start, and now we have read two characters, which means now the pointer is 2 bytes away from the starting index. Okay. So this is the use of ftell. It will give the current position of the file pointer. Now suppose if I have to move that pointer, I can use another function which is called as fseek. So when we are dealing with fseek, we are having three arguments. One is the file pointer, then we will be having an offset. Offset could be negative value as well, based on where we have to move to the right or to the left of the pointer. Suppose if we have to move backwards, we will be giving negative value, and suppose if we have to move forward, we will be giving positive value. And then we will be giving a position, which means where you have to start from, whether it has to be from the start of the file, or whether it should be from the end, or whether it should be from the current position. Okay, so you can use integer values for that. Suppose if we are giving the third parameter as 0, it means that with an offset it will be moving from the beginning of the file, and if the value is 1, 1 denotes the current position. So the offset will be moved from current position of the pointer, and if the position is 2, it denotes the end of the file. So if you see the next line, fseek fp minus 6 2, 2 means the pointer will be at the end of the file, and from the end of the file it will be moving 6 bytes backwards. That is what minus 6 is there. Okay, and then we are going to check the position. So we will see what we are getting. Here you can see the value is 340, which means the file size is actually 346 bytes. So here the point has moved to the end, and then the offset is minus 6, so it moved backwards to 6 bytes. Okay. So if you say f gets, it will be reading the last 6 characters. If you display it, you can see that. So that is about fseek function. And suppose if you have to move from the beginning, you can say 0. Say suppose if you say 5, it will move to the fifth byte. The pointer will be moving to the fifth byte. And if you say 1, from the current position of the pointer, it will move 5 bytes to the right. Okay. So that is how fseek function works. So now we are clear about ftell and fseek. Ftell tells the current position, and using fseek, we can move around the pointer. Okay. And a similar function is rewind. It is used to reset the pointer to the beginning of the file. So wherever the pointer is, when you use a rewind function, the pointer will be set back to the beginning of the file. Okay. So it is same as writing fseek fp00. We are moving 0 byte, that is the offset is 0, and from the beginning of the file. It means this is also serving the same purpose of rewind. And the difference between fseek and rewind is that fseek returns an integer value. If it is a successful operation, it will return 0. And if it is a non-zero value, the meaning says there is some error in fseek function. Whereas in the case of rewind, it is not giving an acknowledgement. Okay. So it will be better to use fseek function for seek. Okay. Now if you check the position, as the pointer is moving to the beginning, it will be again 0. We will see whether we are getting 0 at the end. Here you can see initially it was 0, then using fgetC we have moved 2 bytes, then fseek fp 5, 1, from the current position it has moved 5 bytes, which means now the pointer is 7 bytes away from the start. Then next was fgets, which means the remaining line was red. If you see the first line, already the pointer is 7 position away, so the remaining line is hij that has been displayed. And then we have done an fseek 00, which means the pointer is pointed back to the beginning of the file. We are checking the position, and here you can see we are getting it as 0. I hope it is clear for you. So these are the different file handling functions which is used to access contents in a random manner. Thank you.